Welcome back to the deep dive. Today, we're pulling a stack of sources to analyze one of the biggest shifts happening in tech right now.
We're talking about the rise of autonomous AI coding agents.
And this isn't just autocomplete anymore, is it?
Oh, not even close. We're talking about systems like Devon or Codex or Jules. These tools, they can take a high-level goal, write code across, multiple files, run tests,
Fix their own errors.
and then deliver a final pull request ready to merge. It's a whole new paradigm.
It's a massive shift. And what our sources are showing is that the engineer's role is, well, it's fundamentally changing. You're not just executing anymore.
Right. You're becoming more of an engineering manager. You're overseeing multiple parallel tasks that you've delegated to these AIs.
So our mission today is really for anyone who's using these tools or, planning to, we want to get past the hype.
Exactly. We need to uncover the tactical secrets, the things senior engineers are doing to get these huge productivity gains. We're talking 6x, maybe even 12x leverage.
But only if you get the new workflow right.
And critically, only if you know how to avoid the really surprising technical pitfalls these systems have.
Okay, let's start there. Let's unpack this by talking about time management, because the first step to that 10x gain seems to be understanding sync versus async agents.
This distinction is it's crucial. It dictates your whole workflow. Most people are using what we call synchronous tools.
Okay, so that's like GitHub Copilot or using Cursor while you're typing.
Exactly. Local, human-in-the-loop assistants, they're fast. You get a response in, 20 seconds to maybe a minute and a half. They keep you in your flow.
But the real game changer, the real leverage, that comes from the asynchronous agents.
That's it. These are the cloud-based systems, your Devons and your Codices, where you delegate a big task, something that runs in the background for, 10 minutes, an hour, maybe longer.
And that's what unlocks true parallelism.
It really is. While the AI is off building some complex API, you, the human, are delegating 3 other tasks or reviewing architecture or talking to a designer.
You're multi-threading yourself.
You're effectively becoming a manager of execution. It's a massive increase in capacity.
Okay, but this is where it gets tactical. Our sources all warn about this semi-async zone.
Yes, the awkward middle. This is a time duration you have to avoid because it actually kills your productivity.
And that's between, 30 seconds and 5 minutes?
Around there, yeah. Imagine you give a task that takes 3 minutes.
Okay.
It's too short to really switch your brain to another complex task, but it's way too long to just sit there staring at the screen.
It shatters your flow state.
Completely. So you have to push tasks out of that time sink. Either make them faster by being super specific,
Or make them complicated enough to be a true delegation.
precisely. The modern workflow is about the human focusing on high-level strategy, the planning and on critical judgment, the verification and testing.
While the heavy lifting, the actual coding, gets pushed into that asynchronous delegated zone.
And that keeps the human brain focused on the high-value thinking that you just can't automate.
Which brings us right to the new core skill, being a good delegator. If this agent is our partner, we can't just give it vague instructions.
You absolutely can't. You have to treat it like a junior coding partner, a very enthusiastic one whose judgment isn't always there yet.
So don't just say what you want.
Say how you want it done. Don't just say add unit tests. You'll get something generic.
Right.
You have to say add unit tests for these 4 edge cases, 0 input, negative values, and make sure all the database mocking uses this specific mock service v2 structure.
You're setting it up for success from the very beginning.
And that means giving it the full context. Tell it where to start, the exact repo, a link to the docs, the main file to look at. You have to practice what some of our sources call defensive prompting.
Defensive prompting, I like that. What does that look like in practice?
It's about anticipating where a junior partner would get confused. A change in one place requires some other non-obvious step.
Like recompiling bindings or something?
Yeah, exactly. You have to warn the agent about that up front. You say, hey, be careful. You'll probably need to recompile the C++ bindings each time before you can run the tests.
You're preempting a failure loop before it even starts.
That's how you save those precious minutes. Now, when it does make a mistake, which it will,
Inevitably.
how do you leverage its best quality? Which is, fixing its own errors.
You give it strong feedback loops.
Strong, structured feedback loops. Agents are fantastic at iterating against a clear error message. This is why we're seeing a huge ROI from teams moving to strictly typed languages.
So moving from vanilla JavaScript to TypeScript? Or plain Python to typed Python?
Yes. The type checking, the CI failures, the linter errors, those are the exact unambiguous signals the AI needs to correct its course.
I can see how that would just speed everything up. What about using these agents to preserve our own flow? What are the immediate handoffs?
Any of the chores, any task that makes you switch context and dig through old stuff.
Like bisecting old commits to find a bug.
That's a perfect one. Or even better, updating all the downstream things. The human ships the feature, and then you tell the agent, okay, now go update the user-facing copy, the API docs, and the internal readments.
That's brilliant. That frees up the engineer to solve the next problem, not document the last one.
And it can also help with analysis paralysis, when you're stuck debating two architectural approaches.
Lexical versus slate for a text editor, for example.
Don't spend a day arguing about it in theory. Delegate it. Have two different agents implement a basic version with each framework.
Then you can compare the real results.
Exactly. You compare the concrete code, the performance, you delegate the grunt work, but you, the human, you retain the critical judgment.
So let's scale that up. What about those bigger tickets, the ones that are like 1 to 6 hours of work and span the whole stack database, back end, front end?
For multi-hour tasks, you need explicit checkpoints. You can't just give it the high-level goal and walk away for 6 hours.
Because it might build the entire database layer on a wrong assumption.
And you won't find out until everything downstream breaks. It's a catastrophic waste of time.
So you break it down. You build in pauses.
You have to. You say, first, plan the database schema and show me the SQL. Wait for my approval. Then, go implement the backend service with these 3 tests.
So you're forcing human intervention at those critical points.
You catch the big misunderstandings early before they cascade through the whole system.
Okay, so if the engineer is now, say, 6 to 12 times faster at execution, that has to change the dynamic with the product team. Where's the new bottleneck?
The bottleneck it flips completely. It's no longer building. It's defining what to build.
Because the requirements.
It's aligning the team around clear, unambiguous requirements that actually make sense. I mean, we're seeing real proposals for teams to hire twice as many PMs as engineers just to keep the pipeline full of clear specs.
This gets to that core philosophical idea in our sources. The prompt is the new source code.
This is Sean Gross' thesis, and it's a powerful one. Think about it. Normally, we compile code, we keep the human-readable source, like Python, and we toss the machine-readable binary.
Right.
But with AI, we spend all this time crafting a perfect, detailed prompt, the spec, and then we commit the generated code. And what do we do with the prompt? We throw it away.
So we're basically shredding the source code.
It's like shredding the source and version controlling the binary. The generated code is just a lossy projection of that original spec. The spec has the intent, the business logic.
All the nuance that the code itself can't capture.
And that prompt needs to be preserved and versioned just like code.
If that's true, then the most valuable programmer isn't the fastest typist anymore.
Not at all. It's the one who communicates most effectively. The valuable skills are now planning, scoping, architecture, delegation, and this is a big one, code reading.
Because you have to be able to verify and own what the agent produces.
When an agent spits out 1,000 lines of code in 5 minutes, your job is to read it, understand it, and own that complexity.
This also changes how we even start writing a spec. The sources talked about using prototypes first.
Yeah, this is a huge deal for product managers. You have tools like V0 or Lovable that let you build a working, clickable prototype in hours, not weeks.
So the old flow of vague idea, messy spec, then an MVP. That's gone.
The new flow is vague idea to a rapid prototype. That prototype goes straight to customers for feedback. That feedback creates a crystal clear spec. And then the AI implements it.
The prototype makes the spec better.
Objectively better.
Yeah.
It forces you to make concrete decisions before an engineer ever starts executing.
And the clarity of that spec is everything. We saw that example of a non-technical person who managed to ship a simple feature.
Right, using Claude Sonnet 4 through a tool like Linear, they didn't write a line of code. They just provided a perfect specification.
It proves the point. If the spec is perfect, the code just follows.
But, this is a big but. We have to talk about the technical limits that can undermine all of this. These agents rely on huge context windows, and our sources detail 4 specific ways that long context can fail catastrophically.
This is why agents sometimes just spin in circles, right?
This is the absolute critical technical insight you have to get. Longer context is not always better. Let's start with the first failure mode. Context poisoning.
Okay, context poisoning.
This is when an early mistake, maybe a small hallucination or an incorrect goal, gets written into the chat history. The agent keeps referencing that history.
And it gets fixated on the bad data.
It becomes obsessed with it. DeepMind saw this where if an agent's goals section got poisoned with an impossible task, it would just keep trying to do the impossible thing forever and never self-correct.
What a nightmare. Okay, what's number 2?
Context distraction. This happens when the context window gets really, really long, like past 100,000 tokens. The agent starts paying too much attention to its own history.
So instead of thinking fresh, it just repeats itself.
It starts repeating past actions from the context instead of coming up with a new plan. It gets lost in the noise of its own past work.
I can see that. It's like a human engineer just reading old Git history instead of writing the new code. What's the third one?
Context confusion. This is usually about tools. If you give an agent a giant list of tools it could use, it gets confused. It starts calling irrelevant APIs that have nothing to do with the task.
Its performance just degrades because it has too many options.
Exactly. And that brings us to the fourth and most problematic one, context clash.
This one sounds bad.
It's a destructive failure. It's when two pieces of information in the context directly contradict each other. So you try to give a really detailed prompt over several messages. The agent's early, wrong attempts are still in the context,
And they clash with the later correct instructions.
causing accuracy to just plummet. One study saw a 39% drop. The agent hits that contradiction and, as the source said, they get lost and do not recover.
Wow. So if the context is that volatile, we can't just wait for bigger models. We have to engineer the agent's environment to help it succeed. How do we build that toolkit?
We need what you call ergonomic tools, not just raw API wrappers. You have to consolidate functions. Instead of separate tools for Findu Sirit and then schedule event bide,
You just make one tool.
you build one powerful schedule event for username tool that handles those steps internally. It keeps the complexity out of the context window.
And what about the output from those tools?
It has to be token efficient. A huge source of hallucinations is cryptic UUIDs or internal database keys.
Sure.
You have to replace those with semantically meaningful names. User, Jane Doe instead of user. A1B2C3D4. It makes the context more readable for the AI.
That makes a lot of sense.
And you should give the agent control over how much detail it gets back. A response format parameter in your tool so it can ask for concise or detailed.
You're trying to prevent that context distraction by keeping things tight.
Exactly. And beyond tools, the environment itself. Customization is non-negotiable. The agent's execution environment must be an exact mirror of your team's.
Same language versions, same packages, everything.
Everything. Down to the pre-authenticated login so it doesn't get stuck on simple stuff. And you need to codify your team's knowledge.
A permanent, version-controlled knowledge base.
Yes. A file like CLIUEMD where you document your team's 7-step process for adding a new service route. You turn a complex task into a simple, repeatable procedure for the agent.
What about the things agents are still just bad at, like heavy-duty debugging or visual design?
You have to be smart about how you delegate. For debugging, don't ask it to fix the bug. Ask it to list the 10 most probable root causes.
You're leveraging its reasoning, not its execution.
And for visual tasks, forget make it pixel perfect to the screenshot. It can't do that well. Instead, you rely on your design system. Ask it to implement this feature using components A, B, and C.
So wrapping this all up, what's the big takeaway for the engineer listening to this?
Your value is shifting. Your job is moving away from just high-speed execution. It's becoming about high-level architecture, about delegation, and about managing these parallel streams of work, the critical judgment, the verification, the ownership that remains fundamentally human.
And the single most actionable piece of advice we pulled from all our sources seems to be this. Be willing to cut your losses early.
Oh, absolutely.
If an agent starts going off the rails, getting stuck in one of those context failure loops, just start over. A fresh, clean, defensive prompt is almost always faster than trying to fix a poisoned conversation.
Embrace the shift from coding to communication.
Because the specification is the source code.
That's the core message.
So if the spec is becoming the new source code, what skills beyond just coding skills like philosophy, clear language, systems thinking, maybe even a bit of literary precision are going to be the most valuable for the next generation of engineers?
Something for you to mull over.
Until our next deep dive.